So, what exactly is the Baltimore phenomenon?
So, if you have used Google Maps or any other map related app, you will notice that maps have these layers and they change as you zoom into the map. For example, if you see here the map of Australia, you have the broad states names and the major cities mentioned. But the more you zoom in, there are more features that appear, roads start appearing, and then there are also the smaller towns and villages that pop up. So there are these different layers, and if you like vary the zoom level, you can see that this changes. So the difference between a paper map and a map like this is that you have these various layers that you have to stitch together to see these various detailing, and it's up to the cartographer or who makes the map to decide what details are to be added at each level.
So, I came across this Baltimore phenomenon when I was looking at a particular YouTube video and then went into a deep dive. But the official or technical term that is used for this is called cartographic generalization, which is the job of a cartographer to try to provide the useful information at a particular scale of a map. You don't need to dump every bit of information into a map at a particular level, and only when they zoom into like really close to a particular city or a place, then you give these further details like the tiny roads and the shops and so on. You don't need to give them when they're looking at a more global map or at the level of a country or so on.
Methods
So
used for cartographic generalization, of which a few are mentioned over here. The first one is selection, where there are a lot of objects which are there in the map when you take a satellite image, which needs to be corrected at different levels because you don't want to see a shop in your neighborhood at a level of an India map. So you have to remove these objects as you zoom out and out. So that is selection. At what level you need what set of objects in the map. And then there's simplification, where there could be a complex geological feature or coastline, something which is has a very complex structure, which is highly jagged, curvy. So you try to simplify these objects because that is what the essential information is needed at a particular scale. You simplify the shape of it and reduce the number of edges to make it appear as a simple shape. Smoothing again is if you have some very rough edges in a particular feature, you try to smooth it out. It's more of an aesthetically pleasing sense of smoothing. So you can see the border of Papua New Guinea and Indonesia being a straight line at this scale, but when you zoom in slowly, you start to see this bump which keeps changing as you zoom in further and further. So it gets more and more squiggly, and when you get really close you get to see that there's actually a river running over it, and this border is shared exactly along the river. So there are actually a lot of mathematical algorithms that are used to correct for this. For example, there is the Raymer Douglas Puker algorithm, and also the Vishwalingam Vyat algorithm. So it's up to the different cartographers and people to decide what method they use to simplify. And then there's aggregation, where you have these smaller objects which when you zoom out doesn't necessarily have to have these boundaries. So you clump it together into one superstructure at a higher zoom level. And there is collapse, where if you don't want to give an emphasis to say this particular stream, for example, you thin it down than it actually is. And the opposite is exaggeration, where roads appear very small in your satellite images, so you enhance it because people use the roads to drive, and the roads need more emphasis there than surrounding objects. Then there's displacement, where you might have different objects colliding with each other because of you zooming in and out. So you need to space it out properly such that you don't have things overlapping. And then there's also classification, uh, where you might have the actual image being like patchy with trees, for example, but in a broader sense, you want to show that it is, say, a national park. So you color it in the same color. Once you zoom out, it slowly starts clumping together and then just becomes a continuous region. So this is an example of aggregation where you have these tinier bits just come together when you zoom out of the map. This is an example from Spain near Granada, where you can see there's this lake and there are these streams that are coming through. When you see the real map, the real image, you see that these streams are actually thick than what they show in the map itself. And also the roads thickness is emphasized because people want to see where these roads go. That's the main purpose people use Google Maps for. So the roads get exaggerated in size than they actually are. And there are these the rivers are thinned down to give more emphasis for the roads. In the same website you have this fun tool where you can see how doing these various things affects how the things change on the map itself. So it's a nice visualization of what happens, but it's not so obvious when you see it in Google Maps itself. It's a very tiny changes that you need to have keen observation to see how they are applied into the map itself. So, what exactly is the Baltimore effect? Is that you have the Baltimore city over here and Washington DC over here. So, both cities with very similar populations, both very important cities in the USA. And what happens is when you zoom out, because they're so closely spaced, one of these cities has to be left out, and that is almost always Baltimore, because Washington, being the capital of the country and has more emphasis politically, it usually gets the higher standing over Baltimore, even though Baltimore also has a similar population. Even when you see it in physical atlases, Washington gets the preference over Baltimore. So this is called as the Baltimore effect because of this. Yeah, for example, if you see the map of Mumbai and Navi Mumbai and you zoom out, so Navi Mumbai and then eventually Thane goes off from the map. And similarly, if you look at Ahmedabad and Gandhinagar, Gandhinagar, even though is the capital of the state of Gujarat, once you zoom out, Ahmedabad gets the emphasis because it's being a bigger city with a larger population. So it's totally up to the cartographer to decide what cities emerge over the other when you zoom out. Singapore and Johor Bahru in Malaysia. Johor Bahru has about a population of 1 million people. When you zoom out, it is Singapore that gets emphasis because its own country. So Singapore gets the emphasis over Johor Bahru. Here you have the Vatican City and Rome, but when you zoom out, Vatican City, even though being a literal country, Rome gets the emphasis because it's just bigger and of larger population. There's Montevideo in Uruguay and Buenos Aires in Argentina. But when you zoom out, Buenos Aires gets the emphasis there.
So the video also discusses about the opposite of this Baltimore phenomenon, something as he terms as the inverse Baltimore effect. So what is that?
So in the video, he explains about the inverse Baltimore effect as well, and gives the example of this particular town in the middle of Australia's huge, vast desert, Alice Springs. So Alice Springs has a population of about 30,000 people, and it's the second biggest human settlement in the Northern Territory after Darwin. So 30,000 people, for context, in Indian terms, the first 300 cities in India have way more population than that. And I read a statistics that The number of men in Indranagar alone is like 37,000. So Indranagar in Bengaluru. So that's how densely populated India is in comparison to Australia. A much broader statistics that will kind of blow your mind is that Australia's entire population is almost slightly more than the population of Mumbai. So that is how sparsely populated Australia is. And the population centers are almost all along the coast because you have this massive desert in the middle. Most of the big population centers are all situated on the coasts. So almost 90% of Australia lives along the coast. Here is a map of the nitrogen dioxide pollution levels in different parts of the world throughout as the days pass. You can see the timer over here, and the major urban centers are along the coast, and that's why you can see in Australia it's mostly along the urban region, the coastal regions, that you see these clouds of NO2 that form over time, whereas here in much denser countries you can see the NO2 distribution is much more widespread across the country, unlike in Australia. When you look at a world map on a typical physical map in an atlas, for example, so for example here you can see that Baltimore didn't make it. You can see a lot of the big Indian cities are missing as well. But when you move down here, you see Alice Springs is mentioned on the map. So why is this? When you see it in the actual image itself, you can see that there's this huge empty space over here.
So the inverse Baltimore effect is that you have so much space. In this specific case of Alice Springs, you have this huge patch of empty space, this huge desert, and Alice Springs sits right in the middle of it, and there's no major human settlement anywhere close by. So that makes cartographers typically add in Alice Springs, even though the population is much smaller than many other big cities, which get missed out even at that same zoom level.
Here is another example of this phenomenon. This is Janet in Algeria, and this place has a population of about 15,000 people. And at the same zoom level, if you move up to Europe, you miss out on some major cities. For example, Switzerland. You don't have Geneva, Zurich, or Bern visible there just because you need to first put the country's name there. And a lot of major cities in Germany and France and even the UK get missed out, which have much bigger populations, just because Europe is a much more dense continent in terms of population, whereas this small town here falls right in the Sahara Desert, so it gets a higher emphasis than at the same level much bigger cities. This again totally depends on the cartographer and the app that you're using, because if you zoom in over here at Algeria, the town doesn't come up even though the other places come up, and you have to zoom much more before you get to seeing the town. There we go.
So I didn't remember about this tidbit that I came across on YouTube until I started traveling within Western Australia, and it was something knowing it through a YouTube channel and like a fact, and then actually seeing this as a thing in Australia, like how so low density is the population distribution here, and it's just something different when you experience it and see the fact actually being true.
So we were starting off from here in Kalbari. There's a national park over here. This was a route we were going to take, which starts from Kalbari, which is Kalbari town, next to the Kalbari National Park, which is a very beautiful place to visit. And from there, go up this road and then reach Denham in Shark Bay. So this was the route in plan, and for some reason I needed the internet to download the maps. I had incorrectly downloaded the maps, so we were kind of having the route only till here. To give context, there's not much internet connections or towers around here to provide data, so you lose data once you leave the major town. So the idea was that when I was seeing this map, it showed me these three places on the way to, and then there's Hamlin Pool over here, and then finally to Shark Bay. So somewhere along the line, I was expecting, because this is a 374-kilometer drive, I would be able to find internet on the way, or a small town where we can stop and sort out this issue. To give context of 374 kilometers, that is roughly about the distance from Paris to Antwerp in Belgium, or from London to Liverpool in the UK, or from New Delhi to Shimla in India, or Bengaluru to Chennai, or New York to Washington DC in the USA. So this is a long drive, and the typical expectation I had after going traveling within India is that you will find something on the way, some little shop or stall, but that wasn't the case. Why? Starting off from Kalbari, so there's Urardi, Neren Meadow, Hamlin Pool. But when we reached over here and then over here, we found out that there's kind of literally nothing over there. So this will explain it further when I change it to the actual satellite image. So you can see that Urardi is just this spot where this road connects to the highway, and that's it. There's literally nothing else around it at all except like shrubs. So it's a empty area with nothing there except that junction, and that junction gets mark on the map even after zooming out and seeing a scale where I can glimpse over 380 kilometers of highway. And so this road is having no other junction until Urardi, and then eventually again in Neren. I hope I'm pronouncing these names right. Again, even though it's showed on the map, there's literally nothing there, another empty spot. So now there's like two spots we have crossed, and there's nothing providing internet or food or any kind of civilization around here.
2 hours later.
And then further up over here, finally in Meadow, this is where we found internet, and it was literally just this one building and a bunch of caravans. So that's it. It's not a city, it's not a town, it's just this uh, what's called a roadhouse in Australia, where people can come and stay when they're going on these long journeys. So that's it. That's that one building and a collection of smaller buildings around it. Uh, yeah, then there was a shop, um, but that's it. Like, and it got an emphasis in such a huge map on Google, which kind of gave the wrong impression that it's actually a significantly big city or town. But no. And then again in Hamlin Pool, a similar case where it was just another uh, bunch of small settlement in a sense, roadhouse, and just surrounding that everything, there's like a solar panel array over here and so on. So the sheer it gets such emphasis on the map itself, but not as much to see there in terms of population when you go to the place itself. Again, there is Nanga, which we just passed through, but we could see the lights. Again, just a single resort is all that is there, but it gets its name on the map. And finally, at Denham, by the way, there's also this place called Useless Loop in Shark Bay. The name of this place is itself called Useless Loop. So eventually, Denham is the major town of the of Shark Bay. So this place had significantly bigger settlement. It felt like a proper town. But the point was that traveling through such a long distance and just finding these three spots, out of which just like two was like just a hotel and nothing else around it. It was just unique. It was new. Yeah, I wasn't expecting something like that.
But also, these places just made it to the map because of the inverse Baltimore effect.
So seeing this actually in reality, that such a sparsely populated area, and the emphasis given on maps is for like a road junction and like a small road house is all it is. Seeing that in person was a very unique experience, because in India you usually go on the road in a highway, you find something or the other uh, constantly. There's the human settlement density is just so huge. You will keep on finding something or the other on the road, even like remote areas like the Thar Desert or the Western Ghats or the Himalayas. And this, in that sense, was very new, and it is something Australians know and live with it, used to it. The outback is extremely dangerous because of such straight roads, and nothing around. If your car breaks down, you have to have the backup and skills to fix it and go, or you need to have the emergency contacts to help you out or something. But it's in a sense scary as well. You're in such a remote place and something happens, you never know. uh, Also, that these roads, because they are so straight, they have no curves or turns or any other changes where the driver has to constantly be actively engaged. There is a constant risk of accidents in these long highways, because there are cases where truck drivers fall asleep in such straight roads, because there is no stimulus of driving and you're changing something or the other. So yeah, that's another aspect of these roads, which don't have any other connections or traffic or uh, curvatures and so on. So there's no other features other than just you keep going straight and straight, north and north and north, or south and south, or east west. So yeah, because it's so uh, vast as a country, or it's a continent of its own, and but also very sparsely populated, you have these unique aspects which I feel aren't seen in, like, say, India or Europe or even the Americas. So yeah, that's something I felt interesting and relatable after seeing it in a video as a fact, and then actually seeing it in person. Hope you liked it. Thanks for watching. See you next time. Bye bye.